Welcome to Master Concepts in Chemistry. In this lesson, we want to learn how to determine the mass of an isotope from atomic and percentage abundance of another. Sometimes you might be asked to calculate the mass of an isotope based on the mass and percentage abundance of another. So first of all, to do that, you have to recall the following formula. You have to recall that atomic mass is equal to fractional abundance of isotope 1 multiplied by mass of isotope 1 plus fractional abundance of isotope 2 multiplied by the mass of isotope 2 plus fractional abundance of isotope 3 multiplied by the mass of isotope 3, and so on. So you can keep expanding this formula depending on how many isotopes you have. But in this particular problem, we only have two isotopes, isotope 1 and isotope 2. So n add isotope 2. So let's proceed to read the question. The question says that copper has two isotopes. Copper 63 has an atomic mass of 62.93 and an abundance of 69.17%. What is the atomic mass of the second isotope? So what this is saying is you have two isotopes of copper. One, you are giving the atomic mass and the percentage abundance. But the other, you don't have the atomic mass and you also don't have the percentage abundance. So how do you proceed to solve such a problem? To solve this problem, first of all, let's extract the useful information. So to do that, I'm going to draw a table. Okay, so I'm going to draw a table so I'll extract the useful information. So first of all, I'm going to write isotopes here. Okay, and I'm going to write isotopic mass, and isotopic mass usually have a unit of AMU, which means atomic mass units. It's a relative unit compared to something. Okay, and then we have what we call the percentage abundance. So percentage abundance. Okay, and then I'll add the next column here called fractional abundance. So how many isotopes do we have? Two isotopes. So based on the question, copper has two isotopes. So the first isotope, I write first isotope. Okay, and remember the first isotope is copper 63, and the second isotope we don't know what it is. So I'll just use first isotope here, and the atomic mass of the first isotope, which is copper 63, is 62.93. So I'll write 62.93. And the corresponding percentage abundance for this isotope is 69.17%. The second isotope, we don't know what it is. So we'll use the letter X to represent its isotopic mass. So I'm going to write X here. Also, we don't know the percentage abundance. However, we do know the percentage abundance values always add up to 100%. So since we know the percentage abundance value of the first isotope, and there are only two isotopes here, we would subtract the 69.17% from 100. So we'll say to get the percentage abundance value of the second isotope, we'll do 100% minus 69.17%. And once we do that, we'll get our answer to be 30.83%. So now we know the percentage abundance of the second isotope. So this is something you have to keep in mind. Usually, percentage abundance values always add up to 100%. So if you are not told or given the percentage abundance value of one of the isotopes, what you have to remember is that you add all what you have and then you subtract it from 100 to get the percentage abundance value of that particular isotope, like we just did here. So what we'll now do is we'll now proceed to calculate fractional abundance. So fractional abundance is just to take your 69.17 divided by 100 because this is in percent. So we want to express it as a decimal fraction. So we'll do 69.17 divided by 100. So that's fractional abundance. And we'll do the same for the second isotope. So we'll do 30.83 divided by 100. So that's its fractional abundance. Okay. So now, based on the question, we now have the percentage abundance for both isotopes as well as the fractional abundance. However, we only know the atomic mass of just one of the isotope, the first one, but the second one we don't know. Now, if you go back to our formula says that you need to find the atomic mass, you need the fractional abundance of the isotope multiplied by the mass of the corresponding isotope, and so on. So as you can clearly see, since we know the element is copper, that means that we can look on the periodic table and find the atomic mass of copper. And once we do that, we'll then replace our atomic mass with the atomic mass of copper, and then we generate a linear equation and then proceed to solve. Okay, so that is another thing you need to remember. So that means that we know the atomic mass of our element, which is copper. We know the fractional abundance of each of them. So the only unknown is the mass of the second isotope. So what we'll do is we'll say the atomic mass of copper, which is from the periodic table, is going to be 63.55, is equal to the first isotope, mass of the first isotope multiplied by its fractional abundance. So we'll do 62.93 multiplied by its fractional abundance, which is 69.17 divided by 100. Then we'll add up plus the mass of the second isotope multiplied by its fractional abundance. But remember, we don't know the mass of the second isotope, so we use x. So we'll say x multiplied by the fractional abundance of the second isotope, which is 30.83 divided by 100. Okay. So now, as you can see, we just have one unknown, which is x, to solve. Okay. So again, to recap, so to solve such a problem, once the name of the element is mentioned, you can refer to your periodic table, and then you read the atomic mass of the element. And then you then use x to represent the mass of the unknown isotope you are calculating for. And also, since the percentage abundance of the unknown isotope wasn't given, you have to recall that percentage abundance values always add up to 100. So you subtract what is given from 100 to get the percentage abundance value of the unknown. Then after that, you then convert each percentage abundance value to fractional abundance by dividing by 100, as we have. So now we have our equation. So this is now our equation. So we just have to solve for x. So basically, we'll do 63.55 equals to, if you multiply 62.93 by the result you get by dividing 69.17 by 100, you get 43.528681. Then plus, if we divide 30.83 by 100 multiplied by x, you get 0.3083x. So you see, so that is what we have. So now what you need to do is, this is a linear equation that we can solve. As you've seen, this number is with x, but this number has no x, and this number has no x. So we bring like terms together. So we group this, but remember there's an equal sign here. So if we are moving this across the equal sign, it's like we are subtracting this value from both sides. So that means you subtract this value from that side. If it goes, it's positive. So if it goes across the equal sign, it becomes negative. Okay, so we'll do 63.55 minus 43.528681 equal to 0.3083x. They see. So we've moved our value across the equal sign, and now we have our minus sign here. So now the next thing is, we compute the value. So once we subtract, we'll get 20.021319 equal to 0.3083x. But remember, we want x, we want to isolate x, so we divide here by 0.3083. So cancel it, and then we divide here by 0.3083. Remember, if solving a linear equation, if you're dividing by a value, make sure you do the same. What you do to the right, you do to the left. Okay. So once we divide 20.021319 by 0.3083, we will get 64.941028 AMU. But as you've seen, we want to round our value to 2 decimal places, so we just round down. So basically our 2 decimal places will end here, but since the next value, which is 1, is below 5, we just round down, so our value is going to be 64.94 AMU. So this is our answer. So this is the atomic mass of the second isotope. Okay, so again, to recap, normally when given such a problem, you have to remember that the percentage abundance values always add up to 100. So you subtract what is given from 100 to get the value, the percentage abundance value for the missing isotope. And also, since we don't know what the second isotope is, we use X to represent that. And then we proceed to set up our equation based on the general formula for calculating the atomic mass of an element. Okay, so that is it. Thanks for watching.